In this video, we're going to talk about what the transient response of a circuit is. So whenever something changes in your circuit, there's always going to be a short-term effect and a long-term effect of what's going to happen. So to model this, if we look at this picture here of the circuit, we initially have this capacitor hooked up on the left side, hooked up to a voltage source. And we know what happens when you hook up a capacitor to a voltage source. It's going to slowly or quickly, depending on the values, it's going to charge up the capacitor until the capacitor can't hold any more energy. And in this particular circuit, at some point in time, this switch is going to move and it's going to connect on the right side now. What that means is that capacitor is no longer connected to the voltage source. There is nothing that's going to help charge the capacitor. And instead, what's going to happen now is the capacitor is going to discharge current through that resistor. And so, in the long run, eventually all of the energy is going to get discharged to the resistor, and it would go down to 0 volts, and there'd be nothing left happening in that circuit. So the long-term effect of making this switch would be everything's going to go away. No power, no current, no voltage, no anything. But we're interested in the short-term effect of how quickly is it going to discharge over that resistor, how long is it going to take, and so on. And if we were to graph what's going on here, we have this picture here. So you see at the beginning, we will assume that the capacitor starts out fully charged. So again, it was in the blue position for a long time, long enough for it to fully charge. And then we flip the switch over to the red side, and what's going to happen again is discharge is going to quickly go down and eventually get down towards 0 volts here. And once it's fully discharged, it's going to have the switch flip back over to the blue side, and it's going to start charging it back up with the battery. And then it's going to repeat this and discharges and so on. So this type of graph is how you would have a circuit like this where it charges the capacitor to full, discharges it quickly, charges it back to full, and so on. And we're going to learn how to actually calculate this whole response here. We're going to learn about what the mathematical formulas would be for these different graphs. And we're going to see how you can figure out how much time it's going to take to do this and things like that. And in this particular case, this type of circuit can be used in a lot of real-world situations. This particular one, I believe, came from the flash on a camera, but also, like say, blinkers on a car could operate like this, where it will build up the energy, it'll blink, build the energy, blink, and so on. And based on the values of your resistors and your capacitor, you can change how long this time will be for charging, how quickly it's going to blink. And that's why sometimes in cars, when something goes out, maybe one of the lights goes out and the other one blinks faster, it could be because essentially the Thevenin resistance of the circuit has changed, and it's going to cause the numbers not to work out to where they're supposed to be. So this is the main idea of a transient response. It's going to be what happens in the short term when something changes in your circuit. And in order to solve for that, we're going to need to look at differential equations and how to solve those to get our answer.